Alrighty, Mr. Homeowner. So our customers always appreciate when we kind of describe what's causing wall failure. So it has to do with one, how your foundation was poured. So obviously you have your footing, then you have your concrete floor or slab, and then of course your foundation wall. Now after they pour all these pieces in, they're going to fill that with loose backfilled soil. And over on the left here, you have your virgin compacted soil. Now this is usually pretty sturdy. You can picture, let's say if you dig a hole in virgin soil, maybe like 2 feet deep, the walls are not going to cave in because that dirt has already been compacted over time. But if you went to the beach and tried to dig a hole, what do you think would happen? Exactly, the walls would just cave in like sand almost. It's very loose and unstable soil. So with this being said, all that soil is going to fill in all those gaps up against your foundation wall and cause a serious amount of pressure. So that's cause number one. Cause number two would be water. So obviously the soil is already pretty loose, so it's going to absorb a lot of water. Water actually weighs over 8 pounds per gallon. So as you can picture, this is a lot of weight already. It's causing hydrostatic pressure. So you can picture if you filled up a sink or a bathtub, whatever you want, and then you try to push down a Tupperware container made of plastic, you will watch all of the walls actually bow in because of all that pressure, similar to what's happening to your foundation wall. Now with water there, obviously we're in New Hampshire, it's gonna freeze. Water actually expands at 9%. So if you were to fill up like a plastic water bottle all the way to the top and then screw that cap on, throw it in the freezer, that cap will burst, or the actual water bottle itself will burst open. So similar to what's happening here, there's just so much pressure being put onto this foundation wall, and it just isn't made to handle it. So next I want to go into stages of wall failure for your block wall. So the first stage is horizontal cracking. So obviously your wall starts out pretty straight. Now as that soil back here starts to push, it's going to bow just like that. This causes your first horizontal crack, which is stage one. Stage two, you're gonna have some stair step cracking. Now obviously the sides of the actual foundation wall are the most strongest. So you actually will see the stress through the stair step cracking to these corners. Stage three would be tipping or shearing. So tipping is obviously the wall like this tips forward. And then shearing is actually the opposite. So that's when like the bottom edge kind of kicks out. Now, as you can guess, stage four would be wall failure. Exactly. So I want to preface, you are not here yet, which is great, or else I wouldn't be here. So for a poured foundation wall, same thing happening with the soil here is putting a lot of pressure. So the first thing you're going to see is vertical cracks. And obviously you're going to have your wall, and like I said earlier, the sides of the wall are most strongest. So the actual wall, the middle of it, is going to bow in just like that and cause, vertical cracks. At this stage two, your wall is in 3 separate pieces, as you can see here with that first crack. With your wall being in 3 separate pieces, the one is most likely to move is the middle, which that will start tipping inwards. And I'm sure you can imagine what happens after that. Wall failure. And again, I want to preface, you are not here yet. Next, I'm going to get into historic options contractors have attempted to use to fix an issue like this. So the first one is do nothing. Now, I think you and I can both agree that this is not where we are, or else I wouldn't be here, right? Exactly. Second is DIY. Personally, I'm a huge DIY guy. I have a lot of respect for those people and you like yourself. But the issue is something of this nature is very serious. You have to have a lot of knowledge and the proper tools and equipment. You really can't go to Home Depot and find something to fix something like this. So with you trying to fix it, you're going to aggravate the problem and make things worse, or it's just going to get worse over time. The third option would be total foundation replacement if you would hire a GC. So obviously this is a very, very intrusive process. First, they have to dig out trenches like a moat around your house, dig out the current foundation wall, go in, pour the footing, wait 28 days for that to cure, and then pour the foundation wall, which takes an additional 28 days to cure. So I'm sure you and your wife don't want to be out of the house for 60 days, am I right? Yeah. So with that being said, I'm not sure if you've looked into this, but per wall in this area, I've seen it around 60 to 70,000, again, per wall for replacement. And that's with hiring like a GC. Now the thing with them is they're a jack of all trades. They don't really specialize in something like this. So they're good at a lot of things, but they're not experts at one thing. So our engineers have put together a video to explain a proper solution on a higher level.
When the walls that support your home begin cracking, leaning, and bowing, you may begin to wonder, is this house safe? Unstable walls can create doubt and concern for both homeowners and home buyers alike. When basement walls become a safety concern, the Settle Stop wall anchor system is the answer. Each Settle Stop wall anchor consists of a galvanized plate that's connected to an earth anchor with a high-density 1-inch steel rod. The wall anchor is tightened to combat the forceful soil pressure, which commonly causes walls to fail. The Settle Stop wall anchor system is durable, minimally invasive, and can be installed in as little as 1 day. The installation is straightforward. First, a small excavation takes place approximately 12 feet from your foundation wall. Next, a 1-inch hole is drilled through the basement wall. Then, the 1-inch steel rod is driven to the excavation point outside and attached to the heavy-duty earth anchor. Once in place, the steel plate is mounted on your wall and then tightened to the engineered specified torque reading. Your basement wall is now anchored in dense, stable soils. The Settle Stop wall anchor system is great for customers who want immediate stabilization and adjustability over time. The low-profile wall plates fit between wall studs and are ideal for future basement finishing. The Settle Stop wall anchor system is backed by a lifetime transferable warranty, so there's no need to worry about the structural stability of your foundation wall. We'd rather have you focus on the more important things in life.
So as you can see here, we'd be using the wall anchor system. So imagine a vise. I'm sure you've used one before in the trades at your current job that you told me about. So if once you twist that rod, the vise kind of just clamps in. So the same thing is what we're seeing here. So first of all, we're going to measure the exact anchor locations on your wall from engineering specifications. Then we're going to drill about a 1-inch diameter hole into your foundation wall. After that, we're going to step outside and dig a trench about 12 feet out. Then we're going to hop back inside. We're going to shoot the metal rod into the dirt, into the foundation wall at about a 10-degree angle. That way water can't come back in. From there, we're going to attach the earth anchor plate. Then we're going to attach back inside the wall anchor plate. From there, we're going to tighten that down, which is going to clamp your wall to the virgin soil. That's why it's about 12 feet. We're going that far out. That will fill our goal of successfully stabilizing your walls. Then we have the IntelliBraces. So I know that the joists actually run perpendicular, and you do have a finished basement. So this is part of the wood that we would have to attach. We'd have to cut out that part of the ceiling, and then we would attach a bracket. So in terms of IntelliBraces, same thing with the wall anchors. We'd measure the actual spots where we want to install them with engineering specifications. We actually cut the braces on site for correct measurements. From there, we actually will attach the top bracket to the joist. And then we're going to attach the bottom bracket. And basically, once we're done, the actual IntelliBraces are just going to squeeze against your foundation wall. Now, obviously, there is room for lift, but it gets kind of hairy, but I can definitely introduce some of those options further on. And lastly, we have our carbon fiber bracing. Now, this is by far the least intrusive option. So as you can see here, there's basically black lines. You can put your finished basement walls back over this. Same thing, you do that with the actual wall anchor as well. They're very, very low profile, so you wouldn't have any issues refinishing or finishing your basement. These you can paint over as well. So same thing here, we would mark and measure where would we be installing the actual carbon fiber braces due to engineering specification. From there, we would scarify the wall. We want this to be really smooth. That way the epoxy we lay down will adhere properly. From there, we're going to cut the carbon fiber to the appropriate length, and then we're going to attach the epoxy to the foundation wall. From there, we're going to attach our top bracket with the piece of carbon fiber attached. Then we're going to lay down the carbon fiber to the epoxy on the foundation wall. We're going to use a roller to make sure that's really patted down there. From there, we're going to seal it up at the bottom, and then your walls are permanently stabilized. Now, Mr. Customer, do you think that this option will solve your issue and permanently stabilize your walls? Awesome.